If you recall your previous studies in mathematics, you remember that we can translate any 2D coordinate of x, y into something called a polar coordinate, which instead of thinking of an xy grid where you go from across the x and then up to the y, we can think about the angle that it would take to look directly at it and the distance that it would take to get there, and that's our polar coordinate. So we have that r theta. And so in 2D, we have some sort of either xy coordinate or r theta. Well, there's an analogous way to think about that in 3 dimensions as well, and that's called a cylindrical coordinate. So in Cartesian coordinates, we've already determined you have x, y, and z, so we can traverse those along a grid. But we can also think of this idea of a cylinder, that you have a distance to the point in the xy plane, you have that offsetting angle to get there, and then you have some sort of z value that you traverse upward or downward to get. And here's an example of how we can represent that or sort of wrap your head around it. If I have some point here, which would have an XYZ representation, I can think of its projection into the XY plane, and I can find the polar coordinate representation by finding the distance to the point in the XY plane and the angle, sort of like that heading angle to get there for the polar coordinate. And then I can think about the distance from the XY plane directly upward, and that's my z coordinate. And so notice that the distance from the xy projection is the same distance from the z-axis to the final point, so it kind of creates a plane there. And it's natural to think of this as a cylinder because you have some sort of polar coordinate representation, which is fundamentally like a circle, and then you have some sort of height, so you could think of that as a circle and a height. So every coordinate kind of creates that can of soup representation, similarly to how we think of polar coordinates as everything being along some sort of circle of a radius, and you just rotate to the point that you're trying to get to. And we're going to do some examples about how to convert that, but the way we would want to convert this is similar to the way we would do polar coordinates. In fact, it's identical because the z coordinate is exactly the same in both coordinate systems. Notice that z is not any different. So the same way we did polar coordinates in 2 dimensions, we'll do cylindrical coordinates in 3. So if we are given polar coordinates r and theta, then we can recover Cartesian coordinates simply by performing the appropriate trigonometric function multiplying by the radius or the distance to get there. Now, if you remember, if we have Cartesian, recovering polar coordinates requires a little more care, but the distance is simply just, it's the Pythagorean theorem, like a squared plus b squared equals c squared, so we can get that r, and we can recover theta from this. Y over x is equal to the tangent of theta, and we don't usually say theta is the arctangent because there's some complications there. Remember that the arctangent is not a true inverse of the tangent function, so it has a restricted range of values that come out of it. So we need to be a little more careful. I do want to point out that in cylindrical coordinates, you can have a negative r. It's not recommended. You don't usually want to think of things in terms of a negative r, but even if you did, you could say that if something was at this angle, if it had a negative r, it's just changed by 180 degrees, right? So r positive, if you change it 180 degrees, r is negative, so it's like a double negative because of the way the cosine and the sine function are going to work out for doing that. So just be aware if you're doing sort of example problems and you end up with a negative r, trying to figure out what that means. It's always a good practice when you're plotting these. If you're given coordinates in one system and you're trying to get them in the other system, if you get them and plot them on top of each other, it should make logical sense what you're getting out of it.